Hello everyone. In this video I will be continuing with the carbon family and will tell you about some compounds of carbon, which would be mainly oxides. Okay. So the first oxide which we are gonna start is the carbon monoxide. Okay. You very well know the formula of carbon monoxide, that is CO. Okay. So like this would be our method of studying. We would first see the preparation of each of these compounds, okay, of carbon, and then we would see the properties of each of these compounds. Okay. So the first one would be, how do we prepare carbon monoxide? Okay. So the preparation. Some of you might know when carbon monoxide is produced. Carbon monoxide, like whenever you burn some carbon matter, like you burn wood, okay. So burning of wood produces carbon dioxide, you know this. But along with carbon dioxide, carbon monoxide is also produced. Okay. So the first method which you would say is the preparation for the preparation of carbon monoxide is burning of carbon containing compounds or carbon containing materials. Okay. It is prepared from burning materials which contain carbon. Okay. Okay, and it is produced along with carbon dioxide. Okay, this is the first method. Now you can also produce carbon monoxide by reducing carbon dioxide. Okay. So carbon dioxide, when reduced with carbon itself, which is we say coke, okay. So carbon dioxide gas, when it is reduced with coke, okay, carbon solid, okay, then also we get carbon monoxide. Okay, this is also gas. So this is one of the method of preparation of carbon monoxide. Okay. Now the second method which for the preparation of carbon monoxide, which would be in laboratories, like in laboratory, this is the second method, that is the lab preparation. Okay. In lab preparation, now this was the common method. The first method was the common method in which you can produce carbon dioxide in day to day. In the laboratory method, in laboratory it is prepared by dehydrating methanoic acid. Okay. So methanoic acid is HCOOH. Okay, this is methanoic acid. Okay. So dehydrating methanoic acid would be what? Removing water from methanoic acid. Okay. So this methanoic acid, it would be a liquid. Okay. So what you do that to remove water, what you will use? You can either heat methanoic acid or you can put dehydrating agent. Okay. So one of the dehydrating agent you know is conc H2SO4, that is concentrated sulfuric acid. Okay. So concentrated sulfuric acid at 373 Kelvin, that is heating methanoic acid in presence of concentrated sulfuric acid. What this will do is that it will give carbon monoxide gas plus water would be removed from this. So you can now very well see that what is happening over here. The formula for water is H2O. Okay, so one H removed from here, one H is removed from here, and one oxygen is removed. So what is left? You can see that one carbon and one oxygen is left, and that is what is produced over here. Okay, so this is one of the way of remembering this reaction, that by dehydrating methanoic acid you get carbon monoxide. Okay, it can also be prepared. The third method which we would see is it can also be prepared from oxalic acid. Okay. Similarly to methanoic acid, if you take oxalic acid, H2C2O4, this is oxalic acid. Okay. So if you take oxalic acid again in presence of concentrated H2SO4, which is a dehydrating agent, what this would give? This would give carbon monoxide plus carbon dioxide plus water. Okay. So again you can see that carbon monoxide is one carbon for this and one carbon for this, and there are two carbons. H2O can get 2H from here and 1 oxygen from here, and the rest 3 oxygen would be comprising of O4. Okay, so this is another way of seeing this reaction. Now the third method, okay, is the commercial method. Okay, they would say, sorry, the fourth method. Okay, it is the commercial method of preparation of carbon monoxide. It is the commercial method. So how is carbon monoxide prepared commercially or in a large scale? In laboratory you prepare carbon monoxide in a small scale, but for preparation of carbon monoxide in large scale you need the commercial method. So on commercial scale it is prepared by passing of steam over coke. Okay, it is prepared by passing steam over coke, that is carbon. Okay, so the reaction is carbon which is solid, okay, this H2O gas, that is steam, okay, in presence in temperature 473 to 1273 Kelvin. This is the temperature. Okay, we give carbon monoxide gas plus H2 gas. Okay, now the salient feature about this reaction is that this compound CO gas plus H2 gas, it is called water gas. Okay, this is important and you need to remember this. In fact, you need to remember this entire method, okay, which I am gonna tell you. Okay, so this is called water gas. Okay, and it is used as it can be used as a fuel. Okay, now another method is, if instead of passing steam, if you pass air, okay, if air is passed instead of steam, okay, then what happens? Suppose that you pass air now. So what will happen? This will happen. Okay, carbon solid plus. Now what does air contain? Air contains primarily two gases, nitrogen and oxygen. Okay, so instead of air I am writing oxygen gas and nitrogen gas. This would produce in temperature, and the temperature is 1273 Kelvin. What would this produce? This will again produce carbon monoxide plus nitrogen. Nitrogen is again liberated. Okay, so balancing this reaction you get this. Okay, now again the salient feature about this reaction is that this entire mixture of gas, okay, these both are gases, this is also a gas. So this mixture of gases, it is called producer gas. Okay, this is called producer gas. Okay, and this is also a fuel. Okay, so let me write this down, that water gas and producer gas act as industrial fuel. Okay, they act as industrial fuel. Okay, now the another method of preparation of carbon monoxide is, this would be the, I think, the fourth method. Okay, no, fifth method. Okay, the fifth method of preparation of carbon monoxide is when carbon dioxide is reacted with hydrogen. Okay, so hydrogen is again a reducing agent. Okay, hydrogen is a reducing agent. So what this would do? This would produce carbon monoxide plus water. Okay, this is also one of the method of preparation. Okay, now enough of this preparation. Let's move on to the properties of carbon monoxide. Okay, so we would see the properties of carbon monoxide. How does carbon monoxide behave when water gets reaction with other elements and compounds? Okay, So first of all, let me give you a small description of carbon monoxide. Okay, carbon monoxide is a colorless gas. Okay, it is a colorless gas. You don't see, although carbon monoxide is present in atmosphere also, you cannot see carbon monoxide. Therefore, it is colorless. Okay, it is also odorless. You cannot smell also carbon dioxide. Okay, it burns with blue flame in air, producing carbon dioxide. Okay, so carbon monoxide is oxidized or burnt in air, which is, and it burns with a blue flame. Okay, and produce carbon dioxide. Okay, a very important property that it is a neutral oxide, neither acidic nor basic. Okay, this is an important property, that it is a neutral oxide. Okay, but it is toxic. It is toxic because it forms a very stable complex with hemoglobin, which is present in our body. Okay, okay, so what happens is that it forms a very stable complex with hemoglobin, which is more stable than the original hemoglobin which was present. Okay, so what happens that it causes oxygen deficiency in our body, which leads to unconsciousness and then death. Okay, so if you are too much exposed to carbon dioxide, carbon monoxide, it may cause the death of an individual. Okay, so it forms a very stable complex with hemoglobin. Okay, and this interrupts the flow of oxygen. Okay, and causes unconsciousness and then death. Okay, so carbon monoxide is not good for human beings. Okay, now the next property which we are gonna see is the second property, that is, it is a very strong reducing agent. Okay, it is a very strong reducing agent. Okay, how it is a very strong reducing agent? See the following reaction. Fe2O3, okay, when reacted with carbon monoxide gas, okay, so the iron must be reduced. Iron is reduced to the elemental iron plus carbon monoxide, it reduces and itself gets oxidized to carbon dioxide. Okay, so this is the reaction which shows that here, I hope you understand that how the oxidation and reduction is taking place. Here the oxidation state of iron is how much? It is in +3, but here it is 0. That means that it is reduced. Okay, but carbon monoxide is oxidized. Here the oxidation state of carbon is +2, here it is +4. It is oxidized. Okay, so this shows that carbon monoxide is a strong reducing agent. Okay, the third property is that it reacts with transition metals to form volatile carbonates. Okay, reacts with transition metals, okay, to form to form volatile carbonyls. Okay, the reaction is nickel. Nickel is a transition metal. It reacts with carbon monoxide gas in 28 degrees Celsius to form NiCO4 liquid. Okay. Now, this is one of the properties. Now, the fourth property is that. Okay, let's see the fourth property. Okay, the fourth property is that it reacts with sulfur to form carbonyl sulfide, okay, and chlorine to form carbonyl chloride, okay, or phosgene, okay. It reacts with carbon monoxide gas, reacts with sulfur solid to form carbonyl sulfide solid. This compound is carbonyl sulfide. Okay. Similarly, carbon monoxide reacts with chlorine. Reacts with chlorine gas to form phosgene. This is phosgene. Carbonyl chloride gas. Okay, the another name of this compound is phosgene. Okay, now phosgene is a very poisonous gas. Okay, it is very poisonous. It is very poisonous gas. Okay, so this reaction is very harmful. So it may happen that carbon monoxide may react with chlorine even in atmosphere, okay, and produce phosgene, okay, which may poison people and cause death. Okay. Now another important reaction of carbon monoxide is when it reacts with hydrogen. Okay, this would be the fifth property. Property number 5. It reacts with hydrogen to form methanol, which is of industrial importance. Okay. Okay, the reaction is as follows. Carbon monoxide gas reacts with hydrogen gas to produce CH3OH. Okay, so this is the reaction. Now, the fifth property, property number 6, the sixth property is that it is used for estimating the amount of carbon monoxide. Okay, this property helps in estimating the amount of carbon monoxide. Carbon monoxide is readily absorbed by ammoniacal solution of copper chloride. Okay, CO is readily absorbed by ammoniacal solution. By ammoniacal means the solution in which we add ammonia or the basic solution. Okay, ammoniacal solution of copper chloride. Okay, the reaction is like basically when you react carbon monoxide with CO2Cl2, okay, then what happens is that this compound is formed, CuCl.CO.2H2O. Basically, carbon monoxide is absorbed in the solution. Okay, and this solution is further titrated with iodine and helps in detection of carbon monoxide. Okay, so let me write this down. This helps in estimation. Of CO. Okay, so with this I am over with the properties and the preparation of carbon monoxide. Let's revise that what we studied. So we first understood that carbon monoxide is prepared when we burn any carbon containing compound or carbon containing material. In lab we prepare it by using methanoic acid. Okay, and when methanoic acid is reduced, when methanoic acid is dehydrated, basically when methanoic acid and oxalic acids are dehydrated, they produce carbon monoxide. Commercially, we prepare carbon monoxide by passing steam over coke to produce water gas, and when air is used, we produce a gas which is CO plus N2. Okay, and they both are used as fuel. In the properties, carbon monoxide is basically neutral, it is toxic and forms stable complex with hemoglobin. Okay, it is a strong reducing agent. It reacts with transition matter to form volatile carbonyls, reacts with sulfur to form carbonyl sulfide, reacts with chlorine to form carbonyl chloride, which is phosgene and a poisonous gas. Okay, it reacts with hydrogen to form methanol, which is of industrial importance, and is readily absorbed in copper chloride. Okay, which helps in estimation of carbon monoxide. Okay, in the next video I would be telling you about the another very common oxide of carbon, that is carbon